Bismillah ar-Rahman ar-Rahim. Hello, dear students. Today we will explain Module 4, Lesson 2, Quantum Theory and the Atom. Okay, Quantum Theory and the Atom. Keywords. What's the meaning of matter? What's the meaning of substance? Matter means anything that has a mass and occupies a space, or any object that has a volume. Any object has volume, any object has mass, occupies a space, means matter, means substance. Substance means a physical material. A physical material. Okay. What's the meaning of particles? What's the meaning of particles? Particles, any tiny object. Any tiny objects. Any tiny objects, any small objects. Like what? Like atoms, like protons, like neutrons. Atoms, protons, neutrons means particles. Particles. Okay. What's the meaning of orbit? What's the meaning of orbit? A circular path. What's the meaning of a circular path? Circular path mean orbit. When Earth move around sun in a circular path mean orbit. Okay. What's the meaning of ground state? What's the meaning of ground state? Ground. Ground means low energy. Maybe atom. Atom may be in ground state, may be in excited state. Ground state means low energy. What's the meaning of excited state? When atom is in excited state, what's the meaning of excited state? Excited state mean high energy. High energy. High energy. Okay. What's the meaning of quantum? Quantum means the minimum amount of energy. Minimum amount of energy gained or lost by an atom means quantum. Okay. What's the meaning of photon? Photon is a particle of light. A particle of light. Tiny energy. Any tiny energy, any minimum energy called photon. A photon means a particle of light that has a smallest amount of energy. Smallest amount of energy. يبقى any smallest amount of energy for light, a particle of light called photons. Okay. This picture, waves. What's the meaning of waves? Waves contain crest or trough. Crest. This point called crest. What's the meaning of wavelength? Wavelength is a distance between two crests. Maybe wavelengths may be short wavelengths, maybe high wavelengths, long wavelengths. Okay. This picture that you have in your book is the different wavelengths of colors. Violet color, violet. Red color, here blue color. Violet color has short wavelengths. Wavelengths equal, lambda equal 400 nanometer. 400 nanometer. Nanometer is very tiny distance. Okay. Blue, 270 nanometer. We move from up to down. Wavelengths increase. Red, 665 nanometer. Red color has long wavelengths. The distance between two crests is long. So red color has long wavelengths, has low frequency, low energy. But violet color has small wavelengths or short wavelengths. So violet color has high energy, high frequency. Energy and the frequency is directly proportional together. Energy is inversely proportional to lambda wavelengths. Also, frequency is inversely proportional to wavelengths. If you have short wavelengths, you have high frequency. In red color, if you have long wavelengths, you have low frequency, low energy. This is the different wavelengths of color. Okay. Critical thinking is UV. UV means ultraviolet light. Ultraviolet light, safe or dangerous? Maybe I think safe or dangerous. I think dangerous. Why? Why UV ultraviolet is dangerous? Why? Explain why UV is dangerous. Why? In this figure that you have in your book, visible light has a long wavelengths, has low energy, low frequency. But ultraviolet light has short wavelengths, has high frequency, high energy. So ultraviolet is dangerous because UV is dangerous because it has high energy, lower wavelength. Okay. Now we will explain Bohr's model of the atom. Bohr's model of the atom. What did Bohr say? Bohr explained the structure of atom. The structure of atom, nucleus in the middle, and electron move around the nucleus in a circular path called orbit. Atom contain 7 orbits only. Okay? Electron in orbit. Electron cannot be between orbit. Not here. Electron cannot be here. Electron is in orbit. Electron move around the nucleus in a circular path in orbit. This is the structure of atom. This is called Bohr's model of the atom. Okay. Atom is similar to our solar system. In this picture, sun in the middle. Sun is in the middle. Earth move around the sun in a circular path orbit. Earth move around the sun in the orbit, like electron move around the nucleus in the orbit. Okay, electron like Earth, nucleus like sun, because nucleus in the middle, sun is the middle. So atom, structure of atom is similar to our solar system. Small tiny matter, tiny object like our solar system. This is called Bohr's model of the atom. In this picture that you have in your book, make a difference between ground state and excited state. What's the meaning of ground state? What's the meaning of excited state? Ground state means low energy. Low energy. Atom A and atom B. What's the difference between atom A and atom B? Atom A, electron move in the first energy level. Atom A, electron move around the nucleus in the first energy level. So this atom is in ground state. Ground state means low energy. Okay. Atom B, the electron move in a second energy level, move around the nucleus in second energy level. So this atom B is in excited state. Excited state means higher energy. Higher energy, okay. Low energy in ground state, high energy in excited state. Okay. What happens in this picture? This is called photon. Photon is a small amount of energy, particles of light. When electron absorb this energy, the electron will transition from first energy level to second energy level. So atom converted from ground state to excited state. Here in this picture, when electron jump from low energy level to high energy level, this means electron absorb energy called photon. Photon is the minimum energy of the light. Here, Bohr's model of the hydrogen atom. Hydrogen atom quantum number, contain quantum number n1, n equal 1, n equal 2, n equal 3, n equal 4, n equal 5. Atom contains 7 orbits only. First, second, third, fourth, fifth, from up to down. Okay. We found that the energy increased. E2 larger than E1, E3 is bigger than E2, and so on. Radius of a first energy level, radius of second energy level, third energy level. We found that orbit radius increase from n equal 1 to n equal 5. The radius equal 0.05, 0.2, 0.4, 0.8, 1.32. From up to down, we found that orbit radius is increased from energy level 1, 2, 3. Atom contain 7 orbits only. Okay? This is called Bohr's model of the hydrogen atom. Activity. The model of the atom that has the electron move around the nucleus in an orbit. Called what? Called Bohr's model. As a model of the atom that has electron move around the nucleus in an orbit, called Bohr's model. Okay. In this picture that you have in your book, image A and image B. What's the difference between image A and image B? We found the electron in the first energy level. Electron move around the nucleus in the first energy level. So this atom is ground state. Which atom is in the ground state? Image A or image B? Or say image A. But image B, first energy level, second energy level, third energy level, we found the electron in third energy level. Move around nucleus in a circular path in third orbit. So this atom is excited state. This atom is in excited state. Which atom is in the ground state? Image A, because lowest energy. Which atom is in excited state? Image B, because it has higher energy. This picture that you have in your book, this color called continuous spectrum. Okay. And this line, 4 line, red, blue, violet, 4 line, only 4 line color. Hydrogen, called hydrogen is emission spectrum. Hydrogen emission spectrum. We ask, why is the emission spectrum of hydrogen not continuous? Why hydrogen emission spectrum not continuous? Contain only 4 lines. Why? Why hydrogen emission spectrum not continuous spectrum? Why? Bohr's model of the atom will explain this question. Okay. Bohr's say we have atom, contain nucleus in the middle, the structure of atom, first energy level, second energy level, third, fourth, and so on, fifth, seven, okay? If electron transition from high energy level to low energy level, the electron will release energy, will lose energy. Here, when electron transition from third energy level to second energy level, from third orbit to second orbit, the red color will appear. When electron transition from fourth orbit to second orbit, the blue color will appear. When electron transition from high energy level to low energy level to second energy level, n equal to, this color will appear. So hydrogen emission spectrum contain 4 color only, called visible series. Visible series or Balmer. This is very, very important to know this name, Balmer. When electron transition in hydrogen atom from high energy level to low energy level, okay, it's called visible series. Second energy level, okay. And we can see this color. But when electron transition from high energy level to third orbit or third energy level, infrared series, the electron will release energy in infrared series called Bashan, infrared, n equals 3. This infrared will appear, we cannot see infrared, okay? And electron transition from high energy level to third energy level, the infrared series will occur, okay? Called Bashan. And we cannot see. We can not see. We cannot see. We can see visible light. We can see visible light, visible series, Balmer, when electron transition from high energy level to second energy level, n equal to. If electron transition from high energy level to first energy level, violet series, Lehman, N equals 3. When electron transition from high energy level to first orbit, first N equal 1, this means Lehman N equal 1 when electron transition from N2, from 2 to 1, from 3 to 1, from 4 to 1, and so on. The violet series will appear. We cannot see this violet series. We cannot see violet series, okay? We can see only visible. يبقى if electron transition from high energy level to first energy level is called Lehman ultraviolet. When electron transition from high energy level to second energy level, this is called Balmer. This is called visible series will appear, red, blue, and violet. When electron transition from high energy level to third orbit or third energy level, N equals 3, this is called Bashan, infrared, and we cannot see. But we cannot see infrared, IR. We cannot see UV. We can see visible series. So in this picture that you have in your book is very important to understand, to explain hydrogen emission spectrum for line of color Bohr's model of the atom. Okay, thank you students for understand Bohr's model of the atom. Thank you.